good morning, everybody, to our second episode of our popular DIH Talks. This time on a Wednesday, because it's a special week with a public holiday tomorrow, and we were afraid that on Friday not many would be able to make it, so we moved it to Wednesday, and we welcome about 50 people that have registered for this webinar. So welcome again. And before entering into the subject of additive manufacturing and 3D printing, uh, just a few information about this platform in case you are joining us first time. First of all, this webinar is recorded and will be available via this community platform that we use here, and secondly also via our YouTube channel from Luxinnovation. Then on the upper right hand side you find a few elements. The, the usual one, I would say, you know from all the platforms. On the left hand side it's called discussion, which is nothing else than a chat function, a chat to everybody that is participating in this webinar. For the Q&A sessions, and we will have two today, please use the question section, because I will keep a close eye on that area, whereas the speakers are focusing on their presentation. And we have interactivity, and here I placed already a poll that I will also announce in a moment. And that's actually it from a housekeeping viewpoint. So we are going to talk about additive manufacturing and 3D printing, which is surely not latest technology anymore, I would say, but we often, from a DIH viewpoint, having discussions with clients, with potential users, that there is a feeling it's only used for prototyping. And actually, this is one of many elements that we will see today that where we will try to declare that this is also a reason why to use this technology, but surely not the only one. But before going there, please participate in the poll to have also an idea on the audience and your motivation why you joined today. And I will give the results in the moment where we switch between the speakers. I mean, for introduction and our motivation, of course, the topic came on our radar when we did the survey in December and January from a DIH viewpoint in what topics our community is interested in. And additive manufacturing, 3D printing was rated as one of the highest. But being present also at the Hannover Fair, I have to admit that personally I was quite surprised to find a complete hall that was just focusing on all the different elements that are related to additive manufacturing, which was a bit of a surprise. And if we look into market studies, and there are many market studies, and it doesn't matter which one you take, the growth rates for this technology are quite high, usually ranking between 20 up to 25, 28% annual growth in that business from a global perspective. And in some segments like polymer, even higher. Okay, so let also welcome our guests that we have today. Starting from the left-hand side, we have Pierre Farge, who is just joining us from the Zurich airport. So we might have some noise in the background, but I hope it will not be that bad and it will work out. We have Alan Ruspeller and Nick Royland from Imatec. Imatec, certainly a company that is using the technology quite a lot, also for prototyping, but far beyond that. We have Dean Kaufmann from Amsol 3D Print Luxembourg, a company that is producing but also advising on design elements. And we have today which you did not find in our pre-announcement, we have again our sneak review, and we have one person at the very end as a bit of a surprise, a startup company that I like to disclose already at this moment in time. Now let's start with Pierre. Pierre, welcome, and I'm glad to see that you were able to make it at the airport. I loaded your presentation already, but you have to tell me when I have to switch uh, the the slide for you.
Okay, that's okay. I will. Okay, I will translate. I will talk about. So, do you hear me? It's the first thing.
Yes, we hear you, Pierre, and maybe just to
Okay.
give a quick
So,
introduction of
okay.
your,
So,
maybe you
okay.
introduce yourself
So I do
quickly.
not hear you, but it's not so important.
Okay.
Yes, Saturn company is so Luxembourg company created in 2001, and we were focused on the laser power technology. I am now a shareholder, and we began to make metal 3D printing in 2015. Please, let's go ahead. Yes, we will go ahead. Yes, stop. Thank you. You will see, in fact, Saturn Technology is the 20 people, 4 million euro, and our goal is to make serial production for metallic parts. Our basic process is to use metal, so laser cutting, laser welding, and for example, yes, we did, for example, we took some exhaust parts. Stop at the end. We make exhaust parts and the engine for the aircraft engine for Rafale. About additive manufacturing, we have five big. So the key criteria is to have big machines with roughly 400 millimeters, 400, 400, with four laser in order to have parts which are not too expensive, I would say. Raw material, very important. So at this stage, we have five machines. We are based on raw materials, steel, stainless steel. You could go ahead. And we have a lot of applications with Inconel bars like 718, 625, Astelloy X, and now a new aluminum performance that was not possible to be printed before, like aluminum 2024, 6061. Main focus is Formula One and satellites and space applications. Please go ahead. It's a few examples. So mainly this part are for Safran, for a lot of engine, I will say military engine for Rafale, for the LEAP engine for Airbus and Boeing. And you have injector, for example, and the raw material is mainly Inconel 718 or 65. Please go ahead. This is the mainly part for space, mainly focused in aluminium, where you have RF guides for Thales Alenia Space and other part for Safran, for gas, for General Electric turbines, for gas turbines, so for energy. Please go ahead. Things which is important in addition is that it's not it's one thing to make metal 3D printing. One thing that's important for us, our focus is to make a small batch of production. I mean, small batch or medium-sized production. This means that we have to include all the post-process. This means all the to cut the parts out of the build plate, means with electrics, with automatic saw or EDM, and we have to do all the machining of the surface which are functional, like using machining centers with a 3-axis and 5-axis machining centers. Yes, let's go ahead. Last part is that we will make our heat treatment in-house, which is not usual, and especially in Luxembourg, we are the only one. And the last part is that we make a lot of dimensioning on site, means we make the measurement of the mechanical resistance of the part, of the dimension of the part, roughness, porosity level. So all the criteria that has been fulfilled from our customer has to be checked. Only to say as an example, this process is very reliable and with the accuracy of 0.001 plus minus 0.1 millimeter. You could go ahead. And the slide is okay. Please go ahead. Please go ahead. Go ahead. It's all our measure. Yes. Sorry. Before, if it's possible. Yes. It's thing now. I'm not talking about Saturn. I will talk about what are the challenges for additive manufacturing to make it as a serial production. I will say the main criteria are size of the part, raw material, design, and cost. And our feature is to make to produce part as a machining company, mean with the best quality, cost, delivery time than that traditional process like machining, casting, forging for small, medium-sized production. So first is the size of the part. Please go ahead about the slide. The maximum size we can make now in Saturn, more or less, it's 400 millimeters, 400, 400. And need for customer, if potential customer would like to work with us, will be to have specification like 3D file, 2D file, which raw material, and all the criteria we would like to fit, like mechanical resistance, roughness, tolerances. And when we gave this input, we will give with no cost for our potential customer, cost for prototype, cost for industrial setup, and cost for serial production if the customer thinks about serial production. This means that we receive inputs like machining company, and we get for nothing, for €0 for potential customer, all the cost for prototype setup and cost for production. Please go ahead. Second criteria, the raw material. A weakness from metal 3D printing is that the metal 3D printing, you have not so much powder. And at the end, we'll talk about aluminum powder. What we use as Saturn, we mainly use all the steel without stain. So stainless steel with 316L, 174pH, a specific steel developed for a railway application, Ampo E185, and the other aluminum, raw material, which are aluminum 2024 6061 and nickel based 625 718, and a few percent titanium. Even if Saturn, we do not use at this stage titanium. But things is, when customer goes with a raw material, question will be which raw material, which at the minimum has the same data sheet, I will say, you could use as an equivalent powder. And sometimes, for example, for magnetic application, we do not have powder which fulfills requirements for magnetic application. So this means if customer will go with that, no raw material, no application. Third criteria is design. It's clear that if you go to Saturn and with a design made for machining, we will be more expensive using metal 3D printing. So it makes no sense. So things is, you will have to design your part for additive manufacturing in order to reduce weight, the freedom of shape for no cost. And so when we will get the design, your design of potential customer, you will make a commitment to say, is it possible to print it or not without potential faults, I would say. So it's important to have a design which fit to the interests and to the advantages for metal 3D printing. So only to finish that, we make a simulation, which is very important. Last point, cost. It's okay. Make simulation only to say there is no default. Cost, very interesting will be because we are things with only interesting for short delivery time, complex shape. If we are make spare parts, no tooling is required, makes sense to use metal 3D printing. And to say that minimum cost is €100 per part, minimum delivery time is 4 weeks. So it's not budget I make, but if we go with, it will be not used to make printing. That's over for me. I will do it very short from the airport. I'm ready to answer questions if you have questions. And yes, you have all my inputs, so on my business card if needed.
Thank you, Pierre, and sorry to the audience that yes.
Thank you.
So thank you, Pierre. Thanks again. And a bit sorry to the audience that we could not enter in a Q&A because the flight of Pierre was simply delayed and we had to squeeze it now in something a bit faster. Just to move ahead and just a second to give you also the results of who we have in the audience and why. So about 50 people actually are attending to receive simply an update on related technologies. 25 joined just to get they are interested in the topic, and then it's 2.5 looking for orientation or already experimenting and testing. Quite interesting. And now let's move to Imatec. So I can introduce here Alan Wusperler, who is the managing director of Imatec, and Nick Royland, who is working in the construction design of the machines. And I'm pretty sure we will have quite an interesting discussion on how to use 3D printed material in a manufacturing environment. Thank you, Alan. Thank you, Nick, already.
Thank you. I'm taking the lead just for a few minutes. Okay, let's start. Let me introduce myself. Good morning, everybody. My name is Alan Wusperler, and I'm the managing director of Imatec company. Before to start my presentation, I would like to give a special thanks to Luxinnovation and also to you, Joe, for giving us the opportunity to present our company today. Thanks a lot. Good. Short agenda, but as you can see on it, I will first give you some information related to Tembo Group, our mother company, and also Imatec. And my colleague Nick then will take over and tell you more about 3D printing at Imatec and how we use it. Regarding Tembo, Tembo is a family-owned company which is oriented today in 3 different sectors of activity. So we are present in tobacco business, detergent, but also paper-related business. We have a little bit more than 1,200 people working for Tembo worldwide for the moment, and the group consists of 14 companies. 3 of those companies are OEM. The parent company, which is based in Kampen in Holland, mainly focused on detergent, paper and cut tobacco products. Another company based in Radom in Poland, which is mainly focused on tobacco activities, and Imatec, also at the third OEM in Luxembourg. We are on our side focused on tobacco accessories and paper business. The other entities of the group, as you can see it on it, perhaps are a little bit smaller, but each with its own specificity, and they serve either the 3 OEM or their own customer and own business. But they have really a lot of expertise and technology on their side as well, related either to laser cutting technology, also to OS software analysis, and also efficiency improvement, cold glue, hot melt application process, as well as paper and foil coating and flavoring technology, and specialize also in product development. So it's really not uncommon, and this was again the case when we have developed a paper straw business worldwide through this Tembo group, that most of the company of the group joined their force together, let's say crossover innovation center for the development and the implementation of complex machines and full production lines. Yeah. So combining our sourcing knowledge within the group, materials and technology allow us also to be stronger, to be honest. That's for the main presentation for the group. Now, Imatec a little bit. So closed loop at Imatec, we are currently 48 people, and we had last year an annual turnover around 12 million euro. Imatec exists since 1996 and was owned by Luxembourg cigarette manufacturer Heinz van Landewyk until early in the 2014. Then we joined the Tembo Group. In the recent years, we did specialize ourselves in the development and the manufacturing of high-speed machines, mainly oriented in fine paper technology. This includes process like unwinding, web feeding, gluing, coating, cutting. We have also folding, forming, whatever, also up to the packaging into display box and outer carton box. Yeah? But the most important is also to mention that for all new development projects, we strive to make business case study that take into account production needs as well as the estimated cost of material, resources, maintenance, and return of investment. And of course, determine the total cost of ownership. So this means also that we work hand in hand with our customer, offering continuous improvement and full support of the product and manufacturing level, trying to keep the costs as low as possible and the output high. Yeah? So this is also very important. A little bit about our industry value chain. So what I can say today is that Imatec is, we can say that we are well recognized as a leader in the paper and cardboard-based application, and we have a strong and successful position in tobacco accessories. So using our capacity for machine design and our skill in manufacturing customized entirely and integrated production line or single machine sometimes, as you can see on this table, from concept to finalized product. Yeah. Serving always ROI at the end, so return on investment and OA calculation is also very important. So our aim is to be and to remain a trustworthy innovation partner, but not only a partner that's solely leading in technology, but also had a deep understanding about products, customer needs, and material. So one of our goals today out of this tobacco accessory business is to continue to develop and deliver new sustainable solutions, production processes and machines, and possibly also in different niche markets. Yeah. So that's the first introduction of Imatec company as such within the Tembo Group. And I really do hope that we'll have time at the end to present you one or two movies of our equipment. I will now give the lead to Nick. Nick will continue with the presentation of additive manufacturing in our company.
Thank you, Alain. I'm Nick Royland, and I will tell you about 3D printing at Imatec. And first, I want to start and tell you why did we start with 3D printing. And because in the past we had some very complicated and very expensive parts in our machines. And yeah, the main problem was also that the parts experienced acceleration of 10G. The problem was with the aluminium parts. You see it, the weight was 600 grams, and this affects the lifetime of the bearings. And of this, we decided we have to look for another solution. So at some point, we contacted AMSOL, and with them, we discussed what we can do and how we have to change the parts so they can print them, and that the dimensions will be good after printing, because on some big prints, sometimes it's a problem that there is a bend or something. So at the end, we could reduce the weight from 600 gram to 170 gram for this part, and we could reduce the costs by 55%. And on the next page, you see the second part, and there you can see how we were able to reduce the costs, the weight, and also the internal working hours, because this part was originally made out of 3 parts in aluminium. And due to the complexity of this part, because you see there were very tiny holes, 1 millimeter diameter, they were very expensive. So also with this part, we discussed with AMSO how we can change it. So we translated the design to a one-part design, and with this 3D part, we reduced the weight from 350 grams to 60 grams. And also our cost reduction was this part, because also of the no sampling is needed for this part, we reduced by 70%. And we have a really short delivery time, and the part will be delivered and we can direct put it in the machine. Also, it's good for some spare parts. There is nothing that you have to assemble. You can just send it to the customer and they can put it in the machine. And on the next page, you can imagine these parts were only designed to be 3D printed. And for us, this is a big advantage of 3D printing, because you can design your parts to the intended function and doesn't have to worry about if you can mill it or not. This saves a lot of time, money. And now on this page, you can see what we already print on our FDM printers in-house. So we use it a lot for jigs to control the position on the machine, and also for certain pre-adjustment when you assemble the parts, and also for end-use parts like a belt cover. But mostly you can imagine we use it for fast prototyping. We have a small problem on the machine. Then we design a part that could solve the problem. We print it, and a few hours later or at the same day, you can test it. And if it works, you can purchase more of this to AMSO. Or yes, this is good, big advantage of 3D printing.
Short explanation about our possibilities in terms of machine building and manufacturing and development. I think at the end of the day, everybody is welcome to visit us also, and we can have some discussions. You are kindly invited for a plan tour. Anyway.
Nick and Alan, I was impressed by looking particularly on the reduction of weight with up to 80%. Do you have any experience on those components regarding the quality compared to the traditionally produced products beforehand? Any idea? Did it improve or worsen by using 3D printed material?
Yeah, on the 3D printed part on the surface, yeah, it's normally it's never so good like an aluminium part. When you mill it, you have a surface like normally like glass somehow, but with the 3D printed part, it's has like I don't know how to say. Yeah, it's not perfectly flat, not perfectly smooth surface. But it's for our technologies are good, and for surface that needs to be good, like an aluminium part, we can also just mill it after printing. A lot of parts we get from AMSO when we have to perfect positioning of the part. We take it on the machine, 5 minutes working on our one surface or two surfaces that we have. Maybe in perfect 90-degree angle to mount it, so we take it short on the CNC.
Yeah.
Okay, thank you. We did not receive any questions so far from the audience. Maybe something is still coming, but Nick, knowing your background as well and how you started due to the interview we had beforehand at Imatec, what would you say, since you are responsible for the printers when doing prototyping and things like that, how long it took you to really familiarize with the technology? What would you say?
Not long. And it was we had already a printer here when I began here to work, and then we bought 2 more printers, and yeah, just I would say 1 month, and all the engineers are prototyping some parts just for testing. Before they purchase 100 parts of them, they just want to print it, and just test of if everything works, and then purchasing 100 parts. So it lowers the risk if you that you make a mistake on some parts.
Quite interesting insights, I have to say. I mean, seeing the results also on the cost reduction as you presented it, knowing also now and hearing from you personally, Nick, that I mean, to get the hands around the related technology is not that difficult. Maybe that encourages the one or the other from the audience to invest in that direction as well. I don't see any other questions, and since we are slightly behind timetable, I would recommend we move ahead if you don't mind. Thank you. Then let me just start my next one, which is coming. So the next one on stage will be Dean, and Dean founded AMSOL already in 2017 as a startup company, incubated under the Paul Wood incubator. And if you see the CV of Dean, it's all about product design, design optimization from university time up to what he does today. Quite impressive. Dean, the floor is yours.
There's my presentation. Okay, good. So thank you, Joe, for the short introduction, and I'm welcoming everyone to my presentation. I am Dean Kaufmann, CEO of AMSOL, Luxembourgish, as you may notice from my accent. First, I will give you an overview of our services. Then I will highlight the advantages of additive manufacturing. And at the end, I will talk about the trends and the future from our point of view. AMSOL is the actual name of the company, a shortcut for additive manufacturing solutions, but we are better known in Luxembourg for our website and our services, 3dprint.lu. About us, AMSOL was founded in 2017. Our offices and our workshop are located in the Paul Wood incubator. We are specialized in additive manufacturing and engineering for additive manufacturing. Our customers are ranging from private individuals to startups to big industrial companies, which benefit of the possibilities in additive manufacturing and overcome the constraints of traditional manufacturing. Our yearly production rate is between 15 and 20,000 parts, from which roughly 80% are individual parts. Our references, we are mainly active in the following industry sectors: manufacturing industry, where we do serial productions of AM parts and 3D scans; railway industry, mainly for spare parts; aviation industry for tooling and training supports; automotive industry for spare parts and tooling; space industry for 3D scans and manufacturing fixtures for assemblies; defense industry for spare parts, 3D scanning and full-size replicas; research institutes for prototypes; and trophies for special events, a niche market we found along our journey. Let us jump to our solutions or services. Beginning with our core service, the additive manufacturing as a production on demand, where we have 15 materials ranging from various plastics to metals, divided into 7 different AM technologies. For every material, there are different options for post-processing the parts, for example, tumbling or shot peening or vapor fusing. So the post-process is mostly dedicated to surface treatment. To make it easier and not getting lost in all the specifications of our materials, we distinguish 3 material categories: powder-based materials such as nylon, polypropylene, and metals; liquid-based materials such as non-transparent and transparent resins, filament-based materials such as PETG or ASA. And if I would stop right here, we would be as good as the wide range of online 3D printing services out there. But I wanted to give you an overview of the connecting services that are crucial for our customers when it comes to additive manufacturing. And I think Saturn Technologies can confirm this as well. In terms, so the CAD design and engineering, in terms of software, we are using SolidWorks and Fusion 360, VX Model for reverse engineering, and VX Inspect for quality control. When do we support our customers with our engineering services? Identification of suitable parts for AM by evaluating the possible benefits, for example, by merging assemblies to one part, weight reduction, or an initial material switch. Specific design for additive manufacturing. For every material and every process, specific design guidelines need to be applied in order to have good results. Optimization for serial production, where quality consistency for larger series is the most crucial aspect. Then the 3D scanning and reverse engineering. Last year, we invested in an ISO-certified portable handheld 3D scanner, which is the most precise and cost-effective way to digitalize and inspect objects. It accelerates the current 3D design process in different phases of our engineering workflow, and wide range of applications can be covered, such as reverse engineering for spare parts. We are getting a lot of demands also from private individuals which are sending in broken parts. Our reproductions allows them to successfully repair machines or household goods where spare parts are simply not available. Planning of complex assemblies in a virtual format by measuring the part environment or surrounding parts. Quality control with a 3D scan to CAD deviation inspection for checking the general dimensions, tolerance control, and deformation analysis. Workshops and educational training. We are constantly reaching out to a younger generation of engineers in various educational institutions here in Luxembourg to teach them about 3D printing and show them how to use simple desktop 3D printers. This helps them to boost their creativity and also be able to build prototypes on their own. Furthermore, we also do offer workshops for companies and are willing to share our know-how on the design guidelines and material options available on the market. So why using AM? Finishing with our service portfolio, let us talk in general about the feedback from our customers and the advantages of AM compared to traditional manufacturing, such as milling or injection molding. To summarize, we have picked 3 main points. Fast iterations on prototypes. For example, instead of ordering one prototype, checking and making adaptations, our customers are ordering multiple versions of the same parts and picking the one that fits the best. Complex geometries, their Imatec, which are using pneumatic systems, is a great example by merging assemblies to one part, cutting the weight and costs, and avoiding manual assembly of the multiple parts. As a side note, drilling around corners is not a problem in additive manufacturing. Adding complexity and removing material at the same time does also result in weight and cost reduction. Additive means by adding material, the price, which is based on volume, goes up or will increase. This enables new possibilities for lightweight parts at a competitive price. 10 years ago, there were discussions or rumors that additive manufacturing would be on its way to replace other manufacturing technologies. The speed increase and efficiency of the production on demand was one of the reasons why companies could reduce their stocks of spare parts. Today, we can say that AM has found its place in the manufacturing industry because of its advantages and is still gaining market shares, although it has its constraints and will not replace any other manufacturing. Until today, its strength lays on single parts and smaller serial production at a competitive price. In our case, up to 2,000 parts per run. But for larger serial production, there is always a crossover point where other manufacturing technologies are more competitive in pricing, which brings us to our next slide. AM trends and the future. The AM market is still developing at a fast rate. We wanted to share our view on the most important developments which are impacting the additive manufacturing industry in the upcoming years. Workflow automation for serial production. Although the printing process is fully automated, there is still manual work necessary by taking out, cleaning, or post-processing and preparing the parts for the specific customers. By adding AI for identifying parts after cleaning and robots for sorting is going to reduce further the cost of additive manufacturing in the future. Quality monitoring during printing is something which is already used in metal additive manufacturing, but is still missing for a lot of machines and processes in plastic additive manufacturing. Especially for plastic powder-based processes, this development is currently in full swing and will be available to a broader extent. AI integration for generative design has become a more viable option to optimize parts. It will allow to reduce costs even further by prioritizing and only utilizing a minimum of material for the applied forces on a part. For this topic, I also invite you to have a look at Raffinex here in Luxembourg. On the material side, we notice an increasing number of materials with specific properties and certifications launching into the market. Last week, we, for example, tested a flame retardant material for a customer. I think it is also worth mentioning that we are testing 10 to 20 new materials every year and informing our customers if a material is a viable option for them. Recycled and recyclable materials. Both are existing for several years now in the additive manufacturing industry, and we see a lot of material suppliers pushing to improve the properties of recycled and recyclable materials. And then we have last, the post-processing was and is still one of the most important topics. So again, post-processing is also surface treatment, especially in plastic powder-based processes where the parts have a rough sand-like surface. Great developments have been made to smoothen the surface by using vapor fusing, a chemical process, or shot peening, a physical process. We are, for example, currently testing also ceramic coatings to enhance the properties of certain parts. So I thank you very much for listening to my presentation.
Thanks, Dean. Very interesting indeed. And I certainly like also the sustainability argument in most of the examples you have shared today. So really quite sympathetic and interesting, and certainly something we should think more about. Meanwhile, we also received the first question from Nicolas, from our audience, basically asking the question on cybersecurity, because with 3D printing, of course, you can send easily CID drawings around, even decentralizing your production wherever the parts are required. What do you see, and how are your customers reacting when it comes to cybersecurity concerns and also IP concerns, generally speaking?
Well, mostly with our customers, we first get an NDA done because of the IP concerns. Then they send over the parts. This can be sent over via, mostly via email. And then, but in our case, everything is stored digitally and with also an hardware or server backup.
Okay, thank you very much. I mean, one of the critical questions we both discussed already up front is also always coming up when you talk about 3D printing with on the general question, is it a production method that is more sustainable in general terms, or is it not compared to a traditional, let's call it CNC turning machine, whatever? You gave me an interesting answer to that one. Would you repeat that in public?
Yeah,
Again,
I will be absolutely honest with you. So when you only compare the machines, an industrial 3D printer running and a milling machine running, the 3D printer is not that efficient in terms of energy consumption than a milling machine. But you have to look at the broader aspect of all the factors. For example, we can, with the 3D printers, as I mentioned in my presentation, we are replacing a lot of broken parts on machines for a lot of individuals out there, because the cost of one part is quite low. That is the actual great benefit of 3D printing. On other hands, in the printing process, you are only using the material which is then bound together for the parts, and the rest of the powder in the machines can be mostly recycled. So we are running the production, and afterwards we have these loose powder which will then be inserted in the next print job. So this is another aspect. And we are also now in development to recycle our parts, mostly in plastic, mostly in PA12, to recycle the parts which doesn't met our quality control or were misprints, and to give these parts like a second lifetime in order to recycle them and regaining material and then inserting material to another printing process, but still in the additive manufacturing.
Okay, Dean, thank you very much for that interesting insight and honest answer on that, because this is really, you find it nearly everywhere where additive manufacturing is mentioned. Just a little detailed questions related to that one. When you see latest machines that are coming on the market, do you see a trend that they are using actually less energy? Or is it staying the same at the moment, and it depends highly on the material you are using?
Yeah, it clearly depends on the material, and for mostly for the last decade, the whole additive manufacturing industry, you try to get on a very competitive level to other manufacturing technologies, and that's why the circularity wasn't, I would say, a priority for the last decade. But it is now, as we have reached that level of quality of the parts, we are now going back to be more efficient and be more in a circular way. On the materials, but also on the new developments of machines.
Okay, thank you very much for that additional answer. And I think for the time constraints, I think we have to move ahead. And I like to, oh, that was, sorry, mistake. Let me just turn on the appropriate presentation. And we are moving now to our sneak review, and the person we like to, and the company we like to introduce today, it's Maxime Delmé from AM to 4AM, also dealing a lot or only in materials, or a lot on materials that is related to 3D printing. Maxime, the floor is yours. Thank you for joining.
Thank you very much, Joachim. I will share my screen. I don't know if it's working properly or...
Yeah, it's coming.
Okay.
Yes.
Excellent. So thank you very much for having me here today. It's a real pleasure to be able to present our company AM4AM. So AM4AM is a Luxembourgish startup founded in 2019. We are basically focused on metal powder. So we are metal powder supplier, and we are providing materials that are specifically designed for additive manufacturing. The three main value of the company are having best-in-class metallic materials with best-in-class performance, enhance the reliability of the supply chain with good, not expensive and reliable materials, and industrial production scale. And also we have a production process that is carbon neutral. So first of all, I want to focus a little bit on the problem we are trying to solve. So it has also already been underlined by the other speakers that additive manufacturing could really help in terms of complex conception, short time development, cost reduction, local on-demand production, waste reduction, supply chain. And it has also been underlined by Dean and by Pierre from Saturn that materials is a key challenge. And you could see that for the metal right now, there is less than 2% of the metal that are used in the conventional manufacturing that could be processed by 3D printing. So this is really a break to the expansion of this technology within the industry. If we are looking, for example, this was our first look to aluminium. In fact, the major problem with aluminium, the classical powder are really inappropriate for sustaining the constraint you're applying by additive manufacturing process. And these constraints are creating and generating a lot of cracks in the structure and porosity. You can see an images of one sample we process with a 7000 series aluminium. So it's full of cracks. If you want to make a parts that would be structural in a aircraft or satellite, it's impossible for the moment. So there is a real need for aluminium to find new materials and new solution for it. And so what are we proposing? So in fact, we develop a cold plasma process. So the idea of this process is to modify powder, aluminium, but it could be applied to other. But in our case, we modify powder by adding small ceramic particles on the surface of the powder. And this will rise to enhance the property. This technology will be able to make hundreds of conventional alloy, not only the aluminium we focused on, but also a lot of different, creating new material, new alloy. Pierre just mentioned, Pierre from Saturn just mentioned magnetic particles. We could think about making powder that and having magnetic properties. Also, we have a reliable supply chain and a short time of development with our first production unit that is already able to produce between 6 and 10 tons a year. And cherry on the cake, our process is CO2 neutral. We are not using any solvent, any chemicals, only gas and electricity in a continuous flux. So in fact, as I mentioned, aluminium just before, we focused on this and developed our first materials, which is called Hyperol for high performance aluminium. It's classical 7000 series powder modified with zirconium derivative that are on the surface of the powder. And you can see, compared to the previous image, no cracks anymore, no more porosity, no more defect. So with this material, we own exceptional mechanical properties. We keep the corrosion resistance of aluminium, and also in terms of process efficiency, it's compatible with the majority of additive manufacturing equipment because the reflectivity of the powder changes, and so we're able to decrease the energy needed of 20%. So just the first look also to this first product. So it's 2 times stronger than the classical aluminium that is printed in 3D right now. I give you a little overview of the powder treated and also their characteristic. Also for companies that didn't have printers in-house, we are able with a French startup that are really used and that we qualify with our powders to provide prototype, and so we address also customers that don't have 3D printers, but also customers that have needs of such parts. And I would just finish with 2 short slides showing the ambition of the company. So as I mentioned, having best-in-class metallic materials. And also for the future, we want really to draw the path towards the circularity. As mentioned earlier, also it's something really interesting with 3D printing because a lot could be recycled, and we can also valorize the scrap from other industry. So this is for the future, and I will just close with our experience team. So we are 2 people working at the company, so it's quite a small company right now. We have 3 advisors that joined end of 2022. We have been graduate from Fit for Start in last July. Already working in a European project hosted at Technoport, and so already a nice journey that we spent. So thank you very much, and I will close my presentation here.
Thanks, Maxime. Very interesting insights into the material. And from my viewpoint, I really like to say that, I mean, the today's session is clearly showing that there is a lot of know-how existing in Luxembourg around additive manufacturing, including also our research institute, starting from List University, SNT, and so on. I mean, there tons of opportunities, and I hope we could demonstrate that today, and that should also encourage other people to start if you have not started to look into that. And therefore also really a special thank to the 5 speakers of today that we had very interesting insights. Already in the interviews we did before, I learned already a lot more about additive manufacturing. So thank you again for being with us today. Little outlook into other activities where we are involved from Luxinnovation and the Digital Innovation Hub. In case you have not registered yet, we are hosting the Smart Manufacturing Week on the 6th and the 7th of June as a physical meeting at the Lux Expo. We will have great keynotes, solutions that will be presented, as well as companies being available with a booth to give it a little bit fair character. And surely it's for our manufacturing sector a huge opportunity for networking and getting to know others that are part of our community. Last not least, little outlook on our DIH Talks. By June 16, we are actually starting a series of 3 sessions, which is related to the survey that we did in December, January, where we had a lot of votings, everything related to data gathering, business intelligence up to the level of artificial intelligence will be covered. And on June 16, we will focus on the data gathering from the shop floor, as well as standards on IoT devices, and then move on after the summer break. So thanks again for joining us today, and it was a pleasure to have those gentlemen speaking up today. If you like to get in contact with them, feel free to contact me or us from the Digital Innovation Hubs. That's our role as being the networking part between all the different actors, from users to enablers, researchers, and so on and so far. So don't be shy, come back to us and we will connect you. Thank you very much and have a great, maybe even a long weekend. Bye for now.